So I got this rocket-themed lava lamp, NASA rocket-themed lava lamp recently, and I realized, hey, wait a second, this could serve as an imperfect analogy to the Kappa mechanism, but it kind of gives a similar representation, visual representation anyway. So pretend this is the core of the star, and there's energy trying to radiate out here and into space. But here is the upper layer of the red giant star. Thankfully, the wax here is red. And see this bubble? It's a different opacity than the rest of the wax. So energy is kind of able to radiate around it, but you can see it's sort of trapped underneath. So if this were a varying opacity of a partially ionized hydrogen within the star, it would actually be a whole layer. So it would kind of go all the way across, and there'd be like another layer on top of it that's kind of sitting there. And as energy gets trapped underneath, eventually it would lift the whole upper layers off into space. The opacity would change to become more transparent. The energy is released, and then the layers would fall back down, and you'd have new partially ionized hydrogen changing in opacity again underneath the surface. So eventually, if this kind of works properly for the visualization, the bubble will catch enough energy that it pushes the upper layers above it up. And this is changing in buoyancy for this for the sake of the lava lamp, but for visualization, this kind of shows what's going on with the opaque partially ionized hydrogen within the star. All right, so kind of got multiple things going on here at once. I missed the sweet spot where it first started, but look at that bottom bubble. So you've got energy trapped underneath it. It radiates out into space. Basically the energy is released, and then you have a layer come back down. And, that it's brightest as it first gets released up, cools at the top, and then falls back down. So in a way, this is kind of simulating as best I can as a visual to some of the expansion and contraction of the red giant. Oh, this is a good single blob here. Okay, here we go. All right, so the energy is trapped underneath the bottom. You have it's about to head out. So it's the brightest as the layers start expanding back upward. So here's the star at its brightest and most contracted. Ignore that little blob. Actually, that kind of works too, because you have an opaque bubble that's pushing up the outer layers, which is kind of what goes on in the star. Come on, bubble, go up. I could stare at these things forever. I really could. All right, well, you have a kind of an idea. So that energy at the top is being radiated out into space, and then it's going to collapse back down, and then you get new density and more opaque layers.